Okay, I'm going to begin section 5.5, which is called integration by substitution. Now, if I were to pick one thing that a Calc 1 student would definitely want to know going into Calc 2, it would be integration by substitution. All right. You see, in Calc 2, you're going to be doing lots and lots of things with integration. You're going to see all these techniques for integration along with a lot of applications. And you got to make sure that you've got the fundamentals down. Okay. You're going to be using use substitution like like nearly every day in Calc 2. Okay. And so it's super important if you're if you're moving on here. Now, so far, the integration problems that we have been looking at so far have been just really where it's like you can just go to the answer, okay? Or maybe you got to simplify, one step, and then you can get the antiderivative, okay? But it's a lot of like one line and then you're done type thing, okay? Sometimes a problem is going to require a use substitution, okay? And so here's the substitution rule. It says that if u is equal to g of x, and that's a differentiable function whose range is on an interval I, and f is continuous on I, then the integral for f of g of x times g prime of x dx is equal to the integral of f of u du. Now what you're going to do is you're going to replace a relatively complicated integral by a simpler integral, okay? And the strategy is to look for a function g of x in the integral whose derivative is also in the integral, okay? So here's an example. Suppose I want to integrate x cubed times cosine of x to the fourth plus 2 dx. This would require a u substitution. Now, if I were to let u be x to the fourth plus 2, then du would be 4x cubed dx, okay? Or that'd be the derivative there. And of course, be sure that you keep good notation, okay? Make sure that you've got dx or du or dy or whatever it is. I commented on that several times in the previous videos. All right, now I see an x cubed dx in the integral, so I think this substitution is going to work for me here. In this equation, if I divide both sides by 4, then the x cubed dx part can be replaced with 1/4 du. Constants can come out of integrals, so that constant of 1/4 can come out of my new integral involving u, and then left inside would be cosine of u, since I'm calling u x to the fourth plus 2, du. All right, and you can see that I've now got a new integral that is way easier than it was before, right? Because now I can get to the antiderivative. The antiderivative of cosine u is sine u. 1/4 sine u plus c. Okay, the last thing that you want to do is replace u with x to the fourth plus 2 so that your answer is back in terms of x. So my answer here, I think, is 1/4 times sine of x to the fourth plus 2 plus a constant. All right, a couple more things. Of course, make sure that you're remembering the plus c. We need that. Okay, if we have an indefinite integral, we must have the plus c. And you can check your answer if you want. Okay, you can take a derivative and you should get back to the integrand here. So maybe I could quick check. If I were to differentiate with respect to x, what I think is the answer here, that'd be a chain rule situation. I'm going to have 1/4 times cosine of x to the fourth plus 2 times the derivative of x to the fourth plus 2, that'd be 4x cubed, plus the derivative of a constant is always 0. The 4's would cancel there, and that leaves me with cosine of x to the fourth plus 2 times x cubed. Well, that's exactly what I had in the integrand here. Okay, so I know I have the right answer. I've checked that. You don't need to check your answers, but it's a good idea if you're unsure. Let's take a look at another example. Okay, suppose that we want to integrate the square root of 2x plus 1 dx. This would be another u substitution type situation. If I were to let u be 2x plus 1, then du would be 2dx. Make sure that in your substitution equation here, when you use the differential notation, you got dx. I see students sometimes forget about that. Okay, we need that, even in the substitution part there. If I were to divide both sides by 2 in this equation, the dx part in my integral is going to be replaced with 1/2 du. Okay, now another thing to mention is that du, dx, whatever it is, always has to go at the end of the integral. Okay, like I wouldn't place the du in front of the cosine u part. That's bad notation. Okay, be sure that you're aware of that. 1/2 is a constant that can come out of my new integral involving u, and then left inside the integral would be the square root of u du. And now I can go to the antiderivative. Many times when you make a u substitution, at least for the moment, in Calc 1, you guys can, usually you can then go to the antiderivative, okay? Now, the integrals will become more complicated, as you continue in the calc sequence, but something to keep in mind, we're trying to create a new integral that is easier than it was, okay, initially there. So now I can go to the antiderivative, use the reverse power rule. You're going to have u to the 3/2 times 2/3. The 2's will cancel there. And make sure that you remember the plus c. And then, of course, the last thing, be sure to replace u with the expression that was in terms of x. Always give your answer in terms of x, if x was the original variable there. U is 2x plus 1, so my answer would be 1/3 times the quantity 2x plus 1 to the 3/2 plus a constant. Okay, circle that. When you're making a u substitution, it's a good idea to include any constant that is there. So, notice that I've included like the plus 1, the plus 2. If I were to just let u be 2x, that would be fine. But I would need, in my new integral would be the square root of u plus 1. And I'd have a constant out front, but I would need another substitution then. So try to avoid that, a substitution within a substitution. Okay, it's a good idea to include constants since the derivative of a constant is always 0. Let's take a look at this one. Okay, let's integrate x divided by the square root of 1 minus 4x cubed dx. Well, let's let u be 1 minus 4x squared, because then when I take the derivative of both sides, du would be negative 8x dx. And I've got an x dx in the numerator. By the way, if you have a rational function as the integrand, dx or du, whatever it is always going to go in the numerator. Okay, that will always happen. So I've got an x dx in the numerator. If I divide both sides of this equation by negative 8, the x dx will be replaced with negative 1/8 du. Negative 1/8 is a constant that can come out of my new integral involving u. So the x dx in the numerator, replace that with du. We're dividing by the square root of u. Okay, 1 over the square root of u, that's the same as u to the negative 1/2. And now I can go to the antiderivative in terms of u. Add 1 to the power, divide by the new power, you're going to have negative 1/8 times u to the 1/2 divided by 1/2 is the same as times multiplying by 2. So 2 times the square root of u times negative 1/8 plus c, that'd be the antiderivative in terms of u. Last thing, replace u with 1 minus 4x squared. So my answer here, I'm going to have negative 1/4 times the square root of 1 minus 4x squared plus a constant. By the way, when you make a u substitution, everything about the new integral is going to be in terms of u. Okay, you'd never ever want to have u and x mixed If that were ever to happen, then the substitution that you were using was not correct and is not going to lead to the right answer. Okay, so keep that in mind. When we are selecting the u substitution, when we're trying to figure out what to call u, we want x to go away completely. Okay, x is not going to come back until the very end when we're ready to substitute u in terms of x. Okay. Finding the right substitution is a bit of an art. Okay. There's going to be, sometimes guessing and checking, but it's a good idea to know our derivatives. Okay, like I'm looking for a function g of x whose derivative is also part of the integrand. Okay, I have to know my rules for differentiation. Okay, at least the basics about that. But it is a bit of an art. Okay, and it's not unusual to guess wrong initially. If your first guess does not work, then try another substitution. Okay. So like how about this example? What if I want to integrate sine squared of 3x times cosine of 3x dx? What if I were to let u be cosine of 3x? Okay, then du would be negative sine of 3x times 3 and dx. And that's not going to work because I've got a sine squared of 3x, not just one sine of 3x term, but there's two of them. So I wouldn't have x going away completely if I were to let u be cosine of 3x. Okay, well, let's try letting u be sine of 3x. By the way, I wouldn't want to let u be sine squared of 3x, because then when I take the derivative of that, I'd have a chain rule. It's going to be 2 times sine of 3x times cosine of 3x times the derivative of 3x is 3. And I would have an extra sine of 3x term there, which I don't have in the integral. Okay, so when you're trying to, I guess another thing to add to this would be when you're trying to come up with a substitution, try to keep it simple. Usually you want to avoid powers, square roots. Like I didn't let u be the square root of 1 minus 4x squared, because then I'd need a chain rule. I didn't let u be the square root of 2x plus 1. I'd need a chain rule. I didn't let u be cosine of x to the 4th plus 2, because then I need a chain rule. Okay, so try to keep it simple, at least in your initial guess there with what you're deciding to call u. In this problem, I'm going to let u be sine of 3x. So then du would be cosine of 3x times the derivative of 3x is 3 dx. And I've got a cosine 3x dx there at the end, right? So I'll be able to knock that part out. Can divide both sides by 3. And so at the end there, the cosine 3x dx will be replaced with 1/3 du. 1/3 is a constant, so I can pull that in front of the integral. And of course, du stays inside. U is sine of 3x, so I'm going to have u squared du inside of my integral. And yeah, of course, this is a lot easier than it was initially. I can go to the antiderivative now. It's going to be 1/3 times u cubed divided by 3 plus c, or 1/9 times u is sine of 3x. It would be 1/9 times sine of 3x, the quantity cubed, plus a constant. And another thing too, I would like to reemphasize, if you're not sure about your answer, check. Check by taking a derivative, and you should get back to the integrand there. Okay. Here's another problem. What if we integrate e to the 3x plus 1 dx? Well, if I were to let u be 3x plus 1, du is 3 dx. Now, by the way, I don't know if you've noticed here, but in these substitutions, you'll likely have a constant coming out of your new integral. Now, that won't always happen, okay, but it does happen frequently where you have a constant coming out of the new integral involving u. Don't worry about that, okay, just as long as you can knock out x completely in that new integral. That's the goal. So dx is going to be replaced with 1/3 du. 1/3 is a constant that can come out of the integral. Du will stay inside. You're going to have e to the u du inside that new integral. Antiderivative of e to the u is itself e to the u, and so I'm looking at 1/3 e to the u plus c, and the last thing, replace u with 3x plus 1. 1/3 times e to the 3x plus 1 plus c is my answer on that one. Okay, on the next page here, here's another problem that's going to require a u substitution. And so in this one, okay, you could let u be negative x to the fourth, or u could be x to the fourth. If u is x to the fourth, then you're going to have e to the negative u inside, okay, which is fine. You can still get the same result in that, but why don't we let u be negative x to the fourth in this one. Du is negative 4x cubed dx, and I've got an x cubed dx. Negative 4 is a constant, so when I divide both sides by negative 4, a negative 1/4 would come out of my new integral there involving u. Negative 1/4 times the integral for e to the u du would be my new integral, and antiderivative is negative 1/4 e to the u plus c. Now, of course, make sure that you substitute back. I'll see students just stop and give their answer in terms of u. Don't do that, okay? Whatever the variable of integration was initially, we need to make sure that that variable is the same when we give our answer. Okay, so my answer is negative 1/4 times e to the negative x to the fourth plus c. Okay, here's another one. Let's integrate sine of 1 over x divided by x squared dx. I've mentioned earlier, it is so important that we remember our differentiation rules. Okay, so I've got to see an expression whose derivative is also part of the integrand. In this problem, if I were to let u be 1 over x, or x to the negative 1, then du would be negative x to the negative second, or negative 1 over x squared dx. And I've got a 1 over x squared dx there, so I'll be able to knock out that part completely. I'll have a negative 1 coming out of my new integral involving u. And so the new integral would be negative the integral for sine of u du. The antiderivative of sine of u is negative cosine of u. Replace u there. Negative times negative is positive. So cosine of 1 over x plus a constant is my answer. If I were to quick check that, the derivative is going to be negative sine of 1 over x times the derivative of 1 over x. That'd be negative 1 over x squared. Negative times negative is positive. Derivative of a constant is always 0. You're going to get sine of 1 over x times, divided by x squared there is what we had initially. Okay. Let's take a look at, we'll do one more maybe. By the way, in creating a u substitution, you will never just let u be x. Okay. I will see students sometimes do that, just let u be x. That's doesn't change anything, right? Your new integral is going to be exactly the same as it was, just with instead of x, you're writing u. Well, that's still something that we don't know how to do yet, because we haven't gotten our new integral there. We changed the variable, right? But we still have the exact same expression, and we're not able to get the antiderivative. So, okay, in this next example, I know the derivative of tangent inverse of x is 1 over 1 plus x squared. I see that in the integral, so I'm going to let u be tangent inverse of x. Du would be 1 over 1 plus x squared dx. And so my new integral, I'm integrating u du. Antiderivative is 1/2 u squared plus c. Replace u with tangent inverse of x. So you get 1/2 times tangent inverse of x, the quantity squared, plus c. Now remember that the negative 1 is not a power. So I wouldn't want to write like tangent of x to the negative second power. That's not then now I have a wrong answer. So I'd want to leave it in this form. This would be as simplified as I can get it. Okay. We'll do some more in the next video.